Okay, so today's like going to be lesson 5, and then we're going to have one more lesson, and then we're going to be done with quadratics. Okay, but so you're going to see today how what I was talking about the other day, your ability to factor, is really going to either benefit you or harm you in order to be able to produce these graphs. Okay, so if you recall, Lesson 3 was about producing parabolas when we were provided, or lesson 4, when we were provided the equation written in factored form. Okay, so then we were able to actually, from there, we were going to look at, it was always x minus a number, x or plus or minus a number. We'll just say it's x plus another number. Okay, so this was it in factored form. Okay, and then we were able to read off from this equation, it was x is equal to negative that number and x is equal to negative that number, right? And then we went over to the graph and we plotted it, and then all was good, right? Today I'm going to throw one more wrench in, and this is all it's going to get as hard as it's going to get. Is going to be today, okay, for you guys. So today we're going to be provided the equation in standard form instead, okay? And then so we're going to have to apply our factoring skills in order to switch it to factored form to then produce the graph, if that makes sense, okay? So the only other thing that I would say is we're going to make a connection with maybe some of the earlier stuff that we did too, right? In that we talked about some of the things that we can actually find from each of the three forms of a quadratic, right? And there was a reason why we did each of the three forms, right? So we can, for standard form, there was one thing in particular with standard form that we were able to find, which we'll go over in a second. And then we were able to actually look at how a parabola was transformed. If you remember doing the transformations, that was all about vertex form and finding where the vertex was and what happened to it, particularly the graph, right? And then with factored form, we saw factors led us to basically what we called answers or solutions or roots or zeros, which were the points on the x-axis in which the graph crossed. Okay, and so all three of those forms told us different information that we were able to then go to a graph and produce a graph using each of the three methods. Okay, so one of the things, or the only thing really, that we could find from standard form was one point in particular. Okay, and we could always find, and you can do this too, the more points that you have for a parabola, the more accurate it's going to be, right? So for this particular question, and any question that I provide to you in standard form, okay, that looks like this, you can always go and find the y-intercept. Okay, and how do we do that? Well, we knew the y-intercept occurs here, somewhere along the y-axis. And what's the x value along the y-axis? X equals 0. So what I'm going to do is take that x value and I'm going to plug it in for x. Okay, and I'm going to get a y value out, right? So it's going to be 0 squared plus 6 times 0 plus 8. Well, that's convenient. 0, 0, so the answer in your y-intercept is going to be positive 8. Okay, so that's what happens when you plug in x equals 0. You're able to, basically all you're able to do right away from standard form is read off whatever this number is on the end. We call the C value. We're able just to read that off. This is your C value, is your y-intercept. Okay, and this is the work that shows you y. When I plug in x equals 0, it tells you what the y-intercept is. Okay, so what we can do with that information is actually just go plot that point. So I'm going to go find, in this question, 0, 8, which is right here. That's your y-intercept, right? So now, step 2, you have 1 point on your graph, okay? You're probably going to need 2 or 3 depending on, or sorry, maybe 3, 4, depending on which points you're actually able to find. Okay, so for this question, your second step is to apply your factoring skills. Okay, and by that I mean switch, and by factor, which therefore switches you from standard form, and then puts you into, or I'll just write switches you from standard form to factored, right? And then you can just do all your work from the lesson 4, right? So that's what we're doing. Okay, so we're gonna actually do the work now, right? So I have this quadratic up here, and it's taken the shape of x squared plus 6x plus 8. Okay, it's y equals. Okay, you need to find two numbers by factor. Factor means when you see the word factor, you should automatically think GCF, or I can't go on the grid, or man. That's what's going on in your head. As soon as you see factor, those are the two things that you're thinking of: greatest common factor or man method. Okay, and so now you're going to go down here and you're going to go, okay, I need two numbers that multiply to what, add to what, and then state what those two numbers actually that satisfy those conditions. So I said we always have to go backwards. So I always said the letter A is in the middle of the word man, so the A is going to go in the middle of the trinomial, and then we write the man backwards. So it's M goes on the end. Okay, and so I need two numbers that multiply to 8 and add to 6. You could start at 1 and 8. 1 times 8 equals 8, but it's never going to add to 6. So skip it. It doesn't work. So I'm going to go to 2. 2 times 4 equals 8. 2 plus 4 is equal to 6. So that's both the conditions satisfied. Okay. Once you have these two numbers, that's the hard part of the question over for the factoring section anyway. So then you're just able to write the equation x plus 2, x plus 4. Okay, that's you in factored form. Okay. Now the only other thing I showed you to do from here, and this is the same work as lesson 4 now, we're just putting it all together as a package, right? So this is lesson 3 and 4 combined into one lesson now. Okay, so you're going to have to do all of the work from lessons 3 and 4 to answer one of these questions. We're going to put it together. Okay, so with this now, I have this written in factor form. Let me clean this up. Okay, you just tell me what the roots are, right? So we'll write step 3 is state the roots, or zeros, if you will. Okay, or we'll call it x-intercepts. They're all the same thing, right? So then you're going to go, okay, well, it always takes on the opposite sign of the numbers that are here. Okay, so one of your roots or zeros or solutions or x-intercepts is going to be x is equal to -2, and the other one's going to be equal to x equals -4. Okay, and then so you could write those as points. It'd be -2, 0 and -4, 0. Okay. Okay. Once you have these 2 points, now you have 3 points on your graph, right? So you can go back up here now, and I'll plot them in red so that you can see. One of them is going to be at -2, 0, right? -2, 0 is here. -4, 0 is here. Okay. Now I could do something. I could kind of like just say, okay, well, this kind of looks like this. I could just do something like this. But the problem is I don't know how far the vertex comes down, right? Like I don't know if it's there, and I don't know if it's here, right? Like I have no idea what this parabola looks like depth-wise, right? Definitely not the second one, but who's to say that that's not right, right? So your next step, and basically your final step, is to figure out what the vertex is, okay? So I'll do all this work in blue so that it's corresponding, okay? So your vertex, I'll try to fit it in here. We'll see how it goes, okay? Vertex, you need to figure out. This is step 4. Okay? So you have these 2 points here on the x-axis, right? And if I were to go find the middle of them, in which case here, I'm at -2 and -4. So the middle of those two is actually right here. Right here at x equals -3. This is your axis. Remember, we'll call this axis of symmetry. There's 2 m's. There's 2 m's or not. Okay, so you know, basically the axis of symmetry, x equals -3. Your vertex, the x portion of your vertex is actually -3. Your job is to figure out what the other number is on the side, the y piece, right? You have x, you know that. And so this is the exact same thing as plugging in the x equals 0 to find the y-intercept. You have an x value and you're trying to find a y. So you're going to plug in the value of x into the equation and it's going to spit out a y value. So all you're going to do is do that. So find this number by plugging in this one into the equation. Okay, so I'm going to do this. Y equals, because this is what I'm trying to find, y, and it's going to be -3 plus 2, and then -3 plus 4. Okay, all I did was take -3 and plug it into here for the x. Okay, now I just do the math on this. It's going to spit out a number, right? -3 plus 2 is going to be -1. -3 plus 4 is going to be +1. So y is equal to -1. Okay, and that makes your vertex, the number that goes in here, -1. Okay, so I'm just going to go plot that point. It's going to be right here. I'm going to plot the vertex in purple so that you can see it's -1. Okay. Now the other nice thing about the axis of symmetry is it's like a mirror, symmetrical. So remember, I plotted this point up here. This is the y-intercept that I did in step 1, right? Find the y-intercept, right? And it's actually kind of nice because I have 4 points here, and I have a pretty good idea of what this parabola is going to look like, but I don't know over here. I don't know if it's going to go funny or something, right? So I can actually lock it down using this axis of symmetry, right? So I see that this point here, the y-intercept, is 1, 2, 3 points away from the axis of symmetry. And because the word symmetry means it has to be the same on the other side, I can count 1, 2, 3 boxes this way and plot another point. Now I have this fantastic looking series of points that I can connect and come up with a graph, right? This will be the graph of, you could write it as whatever you want. You could write it as the original, right? This is the graph of, and I'll prove this to you in a second. This is the graph of y equals x squared plus 6x plus 8. Okay? But that's it. Like that's your only job, is to produce this graph given that I give it to you in factored form. Okay? And you're going to use your factoring skills in order to do that. Okay? And just to prove to you that these two graphs are the same thing, I can go into Desmos here. You can do this too, right? You can go into the calculator here, or you can input equations, and this can help you check. It can help you with your factoring. You can do all sorts of things, and I'll show you how it can help you with all of it. Okay, so I'm going to input the equation in standard form, so it's x hat 2. Okay, there's my base parabola. You should remember that one, right? And then plus 6x plus 8. Now, does that or does that not look like the graph I just produced over here, right? So I have negative 3, 1. There's my vertex. There's one of the roots, which I solved for in step 3, right here. Are those not the two roots that I see on the parabola right here? If I click on them, it'll display them, right? And there's the vertex I solved for, right? And there's my y-intercept. Tells you all the points, right? So if you sit there and click on them all, those are all the exact same points I just calculated, okay? Now, let's just pretend here for a second you completely don't believe me that these two equations, if I were to highlight these two equations here, let's pretend that you don't believe me that this is the same thing as this. Okay? Well, I can also overlay another equation here, expression, and you can go y equals, I'm going to type in the equation in factored form. This, right? So I'm just going to type it in. X, and it's going to come up in blue. You can see it's blue. X plus 2, close the bracket, multiply it against x plus 4. It's right on top of, and if I click the blue icon or the red icon, right? If I click the blue, it'll turn to red. So the blue is directly on top of the red, which tells me that it's the exact same equation, okay? So you guys can use this video and you can use Desmos, as I've shown you here, okay, to go back and do a couple questions that I've put at the bottom of this note, okay? So just try to graph each of these using the methods that I've just shown you, okay? So you got 3 of them to do, okay? And this is basically it. I'm going to have a couple more word problems, and that's it for this portion of quadratics, and then we'll move on to something else. Okay, so hopefully this all clears everything up as to the why we were doing what we were doing. This is the goal. Can you produce these graphs, right? This is all Desmos is doing, is the work that you're doing. It's just behind the curtain, right? This is all the behind the curtain work that Desmos is doing in order to actually produce these graphs. Okay, so let me know if you have any questions, okay? That's basically it.